All right, so today's video is going to be pretty short and pretty straightforward. Um, it's just the basic gist of how we set up the hypothesis testing, and it's just like one additional step from what we did last class. So, and then building on all the stuff we've been doing up until now. So an observed difference between two sample means is generally going to have a null hypothesis of this. However, the one we're really going to focus on, and the only one we're really going to cover in this class, are these two. And then the alternative hypothesis. Now, the one word I would tell you about this is that it's hard sometimes to say which way the direction is, and it's easier if you solve for it algebraically. So if your alternative hypothesis is that, then subtract, and you would subtract u sub 2 from both sides, and you get that. Or on the other hand, if you think that mean 1 is larger than mean 2, when you subtract from both sides, then you get that. And sorry, that's kind of cutting off on the bottom of the page there. But what you would see is that these make a lot more sense if you do them. This is generally how you write it, because this makes more sense from when we create the test statistic. But if you think about it this way, it becomes a lot easier to figure out the direction. As always, you're going to have to check the conditions: random, normal, and independent. So the significance test is what we were doing before. The nice thing is most of the time this value is going to be 0, because that's our null hypothesis. And it's a t-statistic because we are using S, the standard deviation, not the standard deviation of the sample as opposed to the standard deviation of the population. To find the p-value, you can use the t-distribution with degrees of freedom given by either tech or n-1, the smaller of n-1 or n2-1. And as before, if it's a two-tailed hypothesis, you double the area. If you use tech, wow, my smartboard's way off. If you use tech, then it automatically doubles it for you, and it will ask for that. And we'll go over using the tech in class. But all of this is just culmination of everything we've been doing so far. Using the T procedure wisely. Now, the good news is that the T procedure is extremely robust against, as we talked about last unit, against normality, and the two procedures are even more robust than the two samples are more robust than one sample. So a lot of times you can get a pretty good thing even when n is as low as, sample size is as low as 5. And so what we need to do to establish normality is, if sample size, this should look very familiar, if sample size is less than 15, if both groups appear normal. And so basically, as long as they are roughly symmetric and no outliers, then we're good. If sample sizes are at least 15, then as long as there's no outliers, like that's all we're worried about is outliers or very, very strong skewness. Right? That would be okay. That would be okay. That would not be okay. Or if there was, an outlier, then we're out of luck. And of course, if sample size is greater than 30, then none of this matters because the central limit theorem kicks in. Right, which is this last part, large samples. When you actually go about, and this is kind of not something that you would use in class, but as we go about this, try and you'll get better results if your sample sizes are as close as possible. It doesn't always work out that way, and especially when you do an experiment, people get disqualified. They don't have to be the same, but the closer they are, the better your results are going to be. We've we've talked about we do not pool data on means, on T procedures. We can use two T procedures for comparing two means in a randomized experiment. A big one. This is a big one here. A lot of times when you get paired data, people will accidentally use the two sample T procedure. Remember, it's two samples, not two data sets. And so if it all comes from one sample or there's only one group, then it's a paired data. And so make sure that if you do this, there are actually two samples from. Beware of making inference. This is going back to chapter 4. Beware of making inference in the absence of randomization. The results may not be generalized to the larger population of interest. And so that's it. We'll do some of those in class. We'll get our p-values, and we will go through the whole four-step process. Declare our null, check the conditions, random, normal, independent, create our t-value, or t-statistic, get a corresponding p-value, and then say in our conclusion, because the p-value is less than the alpha, we reject the null hypothesis and conclude blah, 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 blah. Or, because the p-value is greater than the alpha, we fail to reject the null hypothesis. We do not have evidence that blah, 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 blah. That's really it. Shape is the same as it ever was, you know. So this last two slides that I'm going through right here is just what you should know out of this section of the book. If any of this stuff that is on this slide does not look familiar or you don't know it as you read through it, then you should reread that corresponding section of the book. And if you want to see an example of one of these problems being done, you can look at it in your book. That's it. So that's the video. Like I said, nice and short. We'll be running a whole bunch of problems in class. And I will see you then.